Yeah, this one. Yeah.
Yes, sir.
And the conversion of benzene diazonium salt. Yeah. Okay. So this I think all we did, right? So
Yes.
okay. So this is regarding the all the preparation of aryl halides, right? And aryl halides preparation. Now the reactions. Okay. So what type of reactions do you expect from? Though there are many reactions. Okay. So, but in general, if you try to compare, what type of reaction do we expect from alkyl halides? What type of reaction do we expect from alkyl halides? Any idea? So for that, we need to look at the nature of their bonds. Right, Nabil?
Yes, sir.
So tell me what is the nature of their bonds? Oh, then we will discuss into this. Yeah.
Can you repeat, sir? Nature of the
Nature of the bond between carbon and halogen.
Sir, sp3 hybridized.
Yeah, it is sp3 hybridized. And is it polar or non-polar?
Polar.
Yeah, it's polar. So, and what will this polarity do? Why it is polar?
Because of more electronegative halogen atom, and electronegative halogen atom will pull the electrons
Yeah,
of the alkyl group.
yeah, good. So that is actually the due to the electronegativity difference between the carbon and the halogen, the electron pair gets shifted, bonded electron pair get shifted more towards the electronegative atom, and that's bring partial positive charge on the carbon and the partial negative charge on the halide. Okay, and this partial positive charge is like an invitation to whom? It invites which type of groups are invited to come and join to this
Nucleophiles,
partial?
sir.
Yeah, nucleophiles. So nucleophiles are what? They are electron species. Yeah, they can come in and then they can join. Okay, so a nucleophile can come in and they can join to the carbon atom, right?
Yes, sir.
And that's how the reaction can happen. Okay, but there are another kind of reaction that can also happen. And what this? So this is going to be the substitution reaction. Such type of reactions will be substitution, and because the nucleophile is responsible for carrying them out, so we will call them nucleophilic substitution reaction. And what is another kind of reaction which we are having? Which we will observe on alkyl halide. What is this reaction?
Elimination reaction.
Yeah, and what do you mean by elimination?
Removal.
Yeah, removal, but actually in organic chemistry, what happens in elimination is that the two groups are completely removed. It is a removal of not a single group, but two groups, and no other group take their place. So if the two groups are removed and no other group take their place, okay, so who actually how the bonds of these two carbon atom get satisfied if no other group is coming and taking the place? What will happen to these two? Yeah, they will join among themselves to form a double bond. Yeah. So this reaction is elimination reaction, and this lead to the formation of an alkene. Okay. So that also happens with the base. Actually, a nucleophile and base are one, and they are actually just two sides of a same coin. So suppose if we are having the nucleophile, okay, and if we call it as a base, so it will do the elimination, right? So that's how it happens, okay? So let's discuss it in detail. So what are the mechanism of substitution reaction? Is it clear? And that we will do it in detail. So first do this question quickly. Yeah. Yeah, Nabil.
Sir, A, sir.
So the first reaction is elimination. Yeah, that's true. The second reaction is substitution, because the Br is substituted by OH minus. Yeah. And what about C? The first two are correct.
Sir, I think it's D, sir, because addition.
Yeah, it's addition reaction. So addition is actually just the completely opposite of elimination reaction. So when two groups are completely removed, that is called elimination. And if the two groups come in and join, and the double bond is removed, that is called addition. Okay. So yeah. So by what means we can have this substitution reaction?
Sir, can you just show the slide for 1 moment, sir? I just worried
Yeah.
about.
Yeah. Yeah. Right. Copied.
Yes, sir.
Okay. So suppose if you are removing one group and putting another group, one nucleophile, so you can have different options available depending upon the sequence, and that tells us the mechanism. Okay, right? So
Yes,
tell
sir.
me by what all mechanism the uh, substitution can happen on sp3 carbon.
Substitution 2, sir. SN1 and SN2.
SN1 and SN2, right? So what's the difference actually that you know?
SN1 is carried out in polar protic solvents, and it involves two intermediate steps. Involves one intermediate step, and in the case of SN2, it is carried out without any intermediate steps, and in the SN1 reaction, it is more reactive towards tertiary carbocation, whereas SN2 reaction more reactive towards primary carbon.
Yeah, exactly. Good. So it is simultaneous departure and arrival. So if you are talking about the carbon, we can have only two possibilities. Either the nucleophile can come in and the leaving group can depart simultaneously. Both can happen simultaneously. Okay. Or if you, so can it happen that the nucleophile can come and join and without the departure of leaving group? Can that happen?
No, sir,
Why it can't happen?
because then it will lead to carbon having 5 bonds.
Yeah, it will lead to carbon having 5 bonds. Yeah, correct. So we can't have that. So either you do them simultaneously, or what you can do is you can first remove the nuclear leaving group and then you can bring in the nucleophile. Okay, that is SN1 mechanism. So basics you are already aware of the SN1, SN2 single step reaction, and this is known as concerted mechanism, simultaneous bond breaking and forming, and there is no rearrangements are possible. Rearrangements are not possible. Is it clear?
Yes, sir.
Why rearrangements are not possible? And what do I mean if I say that the rearrangements are not possible?
It means that the spatial arrangement of bonds remains the same, but it is only inverted.
Yeah, actually, yeah, the groups will be connected, will be connected at the same point, yeah, but the inversion of configuration occurs, yeah, because it is just in the one step, so you can't actually change the position. Okay, but if you look at the 3D orientation of the bonds, and if it is a chiral carbon, you observe that there is an inversion happening, and this inversion of configuration happens at the chiral carbon. So why it happens? What is the reason behind it?
Because the other groups will move away from the incoming nucleophile.
Now, actually, because there is a simultaneous attack and departure, so it is mandatory, and that can happen only if the nucleophile attacks from the side opposite to the leaving group. Means 180 degree with respect to the leaving group. Okay. And because of that, we see that there is a inversion happening. Okay. Right? So these two groups actually which are not participating, they flip to the other side just like the umbrella. Flipping of umbrella, okay. When we have a lot of winds, okay, the umbrella get flipped on the other side. Is it clear?
So,
Yeah, and suppose if you take the cis isomer, you will get the trans. Okay, you need to know, you need to write, you need to have the option very clear while writing. Okay, wedge and dash position. So is this clear everything? How to write the answer? Any doubts in this?
sir,
Yeah.
it will only replace the halogen atom, right, sir?
Pardon?
During
It is?
nucleophilic substitution reaction, it will
Yeah.
replace the halogen atom, right, sir?
It will replace, mostly halogens are good nucleophile, good leaving group. So they are replaced. Yeah, but there are other good, OH can also be replaced, but that can get replaced in only in the acidic medium. The other groups can get replaced because, but we are studying mainly alkyl halides, so we are bothered about the replacement of halogens, which occurs most easily. Okay. Right?
Yes, sir.
But there are many other leaving groups. So this is the characteristic of SN2 reaction. Okay.
So can you show that last reaction on the thing?
Yeah. So this is the acetate, which is the nucleophile. It comes in an attack from the backside. Backside is a side opposite to the leaving group. And that is compulsory because you are doing SN2. And what let you decide that the reaction is SN2?
Yes, sir.
How do you decide that it is SN2 reaction?
Like after the reaction takes place or before reaction, sir?
Before the reaction. How do you know that it is SN2 or SN1? Yeah.
No, sir.
Actually, yeah, nucleophile should be aggressive nucleophile, like something which is negatively charged and which can come in and have a tendency to attack. Okay, on its own.
For sir, SN1 or SN2?
SN2 in SN2. SN2 require good nucleophiles, but in SN1, the nucleophiles are no other than the solvent itself. Okay.
Yes, sir. Done, sir.
So SN1 you require, uh, for example, the solvent itself acts as a nucleophile. For example, water. So water, if you look, it is not very good nucleophile. So where the nucleophile just sit ideal, the weight means they are weak nucleophile. Okay, that's what I mean. And the weight actually for the uh, leaving group to come out and form a cation. And if there is a completely developed cation, then only the nucleophile goes in and attack. Okay, not it will not play a proactive role, which we just like what we have seen for SN2. SN2, their nucleophiles are actually okay. They are very aggressive nucleophiles or good nucleophiles. What I would like to say, and they attack. And because it is the both two molecules are colliding and they are reacting with each other, so the rate is bimolecular. Okay, and how the rate get affected by the nature of the alkyl group, that you know, right? Is it clear
Yes, sir.
how the nature of alkyl group affects the rate of speed of SN2 reaction?
Yes, sir.
Okay, that is clear, right? So as you have more and more branching, the rate of SN2, what happens to rate of SN2? It comes down, yeah, it decreases. And on tertiary, there is no SN2 because it is so heavily branched that the nucleophile can't come in and attack, right?
Yes, sir.
Okay. The next other thing is, so among the factors for the rate of SN2, there are many other types of questions which are asked in your NEET and JEE. Okay. So can you compare the rate of SN2 for, this is a very basic question, for all the isomers of butyl bromide or bromobutane? What's going to be the rate, decreasing order of SN2? Yeah, Nabil. Decreasing order of SN2
Yes, sir.
or
One
butyl,
minute.
yeah, butyl bromides.
Sir, bromobutane, then 2-bromobutane, then 1-bromo, 2-methyl propane.
A is the fastest and
D is sir, C is the slowest.
C or D?
Sir, C, sir.
No, D is going to be the slowest one because D is tertiary. It's like this. Can you expect a nucleophile to come and attack directly?
No, sir.
That cannot happen. Okay, because it is tertiary. So no SN2 at all. So what I would like to say that it is going to be, so primary is going to be the fastest. These two are primary. Okay, but among these
No,
A
sir.
and C,
A,
yeah,
C, B, D.
ACBT. Yeah, right. Good. And suppose if you have what's going to be the rate of SN2? In this case,
Recent to reaction.
yeah. Is it the X going to be the faster or Y is going to be the faster?
Sir, Y, sir.
Y is going to be the faster. Why?
Because as X is having partial double bond character on
Yeah,
the
that,
carbon
yeah,
bond.
yeah. Due to which it cannot come out. Right. So suppose if we have this kind of thing, QH aqueous if you take, where the reaction is going to happen, that you know. Okay, where it is going to happen.
Sir, at the methyl group, sir.
Yeah, on the benzylic position.
Yes, sir.
Because that is not the Cl, here the Cl is actually in the resonance. So it is having the double bond character. Okay, so let's do this question. So it is more than one, correct?
Sir, B and C, sir.
Okay. So rate of reaction is independent of the concentration of nucleophile. That's not true. Nucleophile attack on the carbon atom on the side of the molecule opposite to the group being displaced. Yeah, that's correct. A reaction proceed with simultaneously bond breaking and forming. That is also correct. So B and C are correct. Okay. And what about this one?
Yes, sir.
This is difficult question. So don't worry about it. Just do it. Okay. Yeah, Nabil. So let's have them one by one. Right?
Sir, C, sir.
So it is more than one correct. So Cl will react more readily than Br. No, this is incorrect. Okay, because Br is good leaving group. Its bond is weaker and it can break more easily. Right?
Yes, sir.
Okay. So this is incorrect. And what about the second option, B option? Will react more readily than this is true? Yes. B. Correct or not?
No, sir. It will be tertiary carbon, right?
Which one? So this
The
one,
second.
primary one, will react more readily than that.
Yes, sir.
Yeah, it is correct, no? Correct or incorrect?
Correct, sir.
Yeah, it's correct. Okay, good. And what about this one? C.
Sir, I think it's correct, sir.
So this one will react more readily than this. This is, yeah. Actually, though both are primary, you might have studied that the neopentyl halide are almost inert. This is neopentyl. Okay. They are almost inert for nucleophilic substitution reaction. But in spite of being primary, why they are inert?
Steric hindrance, sir.
Pardon?
Steric hindrance.
Steric hindrance, yeah. Because though they are primary, but they are heavily branched. Okay, and that is the reason they are actually, because heavily branched on the carbon atom, just close. Okay. So because of this, we can't have reactions on these. So this is also correct. And this you need to tell me is more readily. Yeah, SN2 actually, yeah, which one is going to be react more readily? This is actually, yeah, these are para isomers. Let me draw them carefully. Okay. Is CH2Br. Okay, and this is OCS. Okay, and this is CH2Br, and this is nitro group at the para position. Okay. So which one will react more readily?
Sir, second one, sir.
NO2?
Yes, sir.
Why?
Because it is electron withdrawing group.
Yeah, electron withdrawing group. So
Increase rate of.
yeah, actually it will increase the rate of nucleophilic substitution reaction. Good. So this one will react. So this is electron donating group. So it react more readily? No. So this one is incorrect. So the right answer is going to be B and C option. Okay. So now there are some mechanism based question which we discussed just now, and that you need to know the mechanism, and based on that you need to decide whether the reaction is going to be fast, whether the reaction is going to be slow. Okay, such kind of questions come. Okay, so in that we need to look at the charge, we need to look at the mechanisms. Okay, that is very, very important. So now the next thing is, there are certain questions which don't ask about mechanism, they are just bothered about the conversion. Okay, so there you need to just convert and tell. Okay, so what is the product which is going to form, that you need to tell. Okay, so this is some of the very, very common nucleophilic substitution reactions. So this, I think it is clear, and there is a name to this nucleophilic substitution reaction. What is the name to this nucleophilic substitution reaction? Tell me. What is the name to this given to this nucleophilic substitution reaction? And it is famously used for the preparation of ethers.
Williamson ether synthesis.
Yeah, it is Williamson ether synthesis, right? Yeah, and this is thioether, and this is amine preparation. Okay, so a lot of reactions are there, and this is the table from NCRT. Okay, so I hope this is clear, because many times the question come on this. Is it clear? Suppose
Yes,
if you are
sir, can you show the above slide?
Yeah. Yeah, copied. Shall we move ahead?
Yes, ma'am.
Copied? Yeah.
None, sir.
Yeah. So these reactions are clear. Actually, these are asked many times. Okay.
Yes, sir.
Okay. So this is the table from NCERT, but it's very important. So that's why I've included it. Okay. So list of reaction, list of nucleophiles. Yeah. Okay. The next thing is SN1 reaction. So SN1 is also known as solvolysis. Why it is called solvolysis?
What's it?
Solvolysis.
Because solvent molecules take part in the reaction.
Yeah, actually solvolysis, actually it is called solvolysis because the nucleophile molecule is none other than the solvent itself. Okay. Clear? So that's why it is called solvolysis reaction. And so here SN2 can't happen because first of all you have taken a weak nucleophile. It's a neutral, so it is not the something which we have seen in the above questions, okay, where the nucleophiles were negatively charged or they were a bit stronger, so they were actually actively participating in the reaction and they were pushing away the nucleophile. Okay, in this case actually the nucleophile is very weak, so it will not have a tendency to go and attack. It will just sit ideal, so it will wait for the leaving group to come out. Okay, this is RDS. Okay, this is unimolecular reaction, and once the leaving group come out and you have a flat carbocation intermediate, then the nucleophile comes in and attack, right?
Yes, sir.
So that is actually how the reaction happens. Okay, so this is the slow step and that one is fast step. Rate is determined by the slow step, the concentration of the, and it is unimolecular because in the slow step only the substrate molecule is participating. So this is all clear and this is the energy profile. Okay, this is the difficult step. You can see that the energy is increasing abruptly, so that's why it is. And these are actually fast steps, so you can check the height of the hump, that can let you know, okay, whether it is slow or fast. So the hump which is having the highest height, okay, from the base, so that is going to be the fastest reaction. That is going to be the slowest step and that is going to be the rate determining step. Is it clear?
Yes, sir.
So yeah, what's the stereochemistry and what are the other factors? So rearrangements are possible and all these things I have written. Okay, let's do this question. So these are actually 3 questions. Okay.
So they just show the earlier slide.
Yeah. Just go through it and let me know if something need to be discussed.
None, sir.
Okay. Now let's do this question.
So first one is C.
First one is C, right? Second one,
Sir, A.
Pvt PPT, both A as well as C also. So D is the right answer.
Sir, how C can you say, sir?
C because it can form a stable carbocation. Actually, C will give the precipitate more readily. The carbocation will be stabilized by resonance.
Yes,
Okay.
sir.
Right.
Yes, sir.
And what about this one? Next question.
Sir, 4, 2, 3, 1.
4 will be the fastest.
Yes, sir.
Why it will be the fastest?
Because the halogen is not attached to the it's not directly attached to the benzene ring, and also it is also having a tertiary carbon.
No, actually, it is not directly. So this portion is same for all. So this portion is not going to, you should not think on this portion because it is same for all of them. Okay. But you need to concentrate on this group. This group is helping the cation to get stabilized. Okay. So you need to know, actually earlier people were not aware. Actually, they used to think that, let me. So suppose if I ask you, what is the stability of the carbocation? Yeah, tell me. Where the carbocations are more stable.
So the fourth case, sir.
Why? Actually, earlier people used to think in this way only. Okay. So, but every time this carbocation, first one used to be most stable one. Why?
Because primary group is least electron donating, and therefore it will not affect the electropositivity of the carbocation.
Actually, you need to be more specific, but this is having more plus side. Okay. This is the smallest, lowest plus side. But this is going to have highest hyperconjugation effect. Remember, we discussed hyperconjugation and no hyperconjugation. Remember that we discussed hyperconjugation.
Yes, sir. Yeah. I'm making
Actually,
the sp3 high electrons
yeah,
available for resonance.
yeah, get involved in delocalization with the adjacent pi. So they will come here, and when they will come here, so they will get to the cation. So cation will become very stable. So earlier people were not aware of the hyperconjugation effect. So they used to think that the fourth is the most stable one because that is the most branched one. And that is the one which is having the maximum electron density. But always what used to happen when they used to do the experiment, they used to see that the first one is more stable, followed by second, third, and the fourth one was found to be the least stable. So it means that there is something which they were not aware of that effect at that time, at that point of time. And what was that something? That something was that hyperconjugation effect. Okay. Hyperconjugation effect was discovered later, right? Initially, actually only the inductive effect and the resonance effect were discovered, right? Okay.
Yes, sir.
So yeah, so that you need to know. In this one, the most stable cation will be for the second, followed by third, followed by fourth, and the first, because it doesn't have any alkyl group at the para position. So the right answer is going to be the A option, right?
Sir, can you say why B will be the greatest?
Which one?
B, sir. Why? How is it greatest?
Because the
Second
car,
option.
because this carbocation is more stable. And why it is more stable? Yeah, tell me.
Why, sir?
Because of the hyperconjugation. Look here. How and hyperconjugation, how do you measure? You measure how many hydrogens can participate in hyperconjugation. Is it clear?
So greater number of hydrogen atoms, greater hyperconjugation.
Yeah. So the methyl group was very small. Electron donation capacity of the methyl group was very, very low. Okay. But actually the hyperconjugation was very much. Okay. And why it was very much? Because it was having maximum number of alpha hydrogens. Is it clear?
Yes, sir.
Yeah. Okay. Yeah. So keep this in mind. Actually, this is the thing where most people make mistakes. Okay. Right. So,
Yes, sir.
and the solvent effect you know already. Polar protic, aprotic. SN1 require protic solvent. Okay. Why? Because the cation and anion need to be stabilized. Uh, and who stabilize the cation and anion? The solvent like this. For example, the water stabilizes the cation and anion. Okay, clear. So, but aprotic solvent actually the SN2 can happen, SN1 can't happen. Why?
Yes, sir.
In aprotic solvent, this is aprotic. Why SN2 can happen? Why SN2 require aprotic? What will happen if you take protic for SN2? Yeah. Aprotic solvent, actually this is negative charge. Okay. Can you see this? The positive charge is actually there, but it is inside the molecule. So if it is inside the molecule, it is of no use. Okay. So these aprotic solvent actually make the nucleophile. Nucleophile is also negatively charged. Aprotic solvent is also negatively charged. So it makes the nucleophile more reactive because the nucleophile actually feels a lot of repulsion. And stereochemistry, you know, stereochemistry for that we discussed for SN2, it was inversion, and for SN1, it is resmization. This is clear? Resmization?
Yes, sir.
Yeah. So this is all the differences between SN1 and SN2, which we discussed. Okay. So I hope this is clear.
Yes, sir.
So let's do the conversion of preparation of alkyl halide, but from the point of view of SN1 and SN2, we need to see. So this is which reaction?
Sir, SN2.
Is this SN2? What's the name of this reaction? You might have seen it in alcohol chapter. Actually, this is common to alcohol and alkyl halide. This is preparation of alkyl halide from alcohol. And this reagent has a specific name also.
Sir, Lucas reagent.
Yeah, Lucas. And this is a conversion, and this is actually a reaction also. So where the Lucas reaction or reagent react fastest? Tell me. And how it happens?
Sir, in primary alcohols.
No, not primary. Actually, tertiary alcohols, it is the fastest. Okay, look here. Why it is fastest? Now tell me.
Sir, tertiary.
Yeah, you know the time for the appearance of turbidity, okay? And it is fastest for tertiary alcohol. Why it happens quickly for tertiary? What's the reason?
Formation of carbocation.
Yeah, it is the carbocation which happens very quickly, and that's why it is the fastest. So this is SN1 mechanism. Just remember it. Okay, that's why the tertiary alcohol. Remember in the alcohol, suppose if you need to break this bond, okay, the rate of the reaction is, so in your CBSE batch the alcohol is completed.
Yes, sir.
Yeah. So in this actually we can go through it quickly. So if you want to break this bond, this breaks with the formation of a carbocation. So the rate is like this. Okay, because in the Lucas you are breaking CO bond. So for CO bond, the tertiary cation is going to be the most stable one, and that's why the tertiary alcohol give this reaction very quickly. You get the turbidity in just 2 to 5 minutes. Okay, and if you get the turbidity in more than 5 minutes, that means what? That is the secondary alcohol. And if you get the turbidity after a long time or only upon heating, or if it doesn't react, Okay, that means what? That means
It is
that,
a primary alcohol.
yeah, it is a primary alcohol. But sometimes the primary alcohol can also react very quickly. Okay, when it is, tell me.
Sir, if it contains other,
Yeah, when it contain a group
like
like this double bond, which
electrometals.
can form a stable carbocation by resonance, then it can happen very quickly. Okay, in this case, it happens very quickly. So all of these reactions are mostly SN1 reaction, and in this actually, yeah, you take HBr or you take NABr. Okay, so this is clear. All these reactions are clear, right? This you have already studied. Okay, any doubt in this? Yeah, Nabil.
No, sir.
Yeah. So this one, this you know, where I'm going to put the Cl.
Sir, on the methyl group.
Yeah, on the CH1, but not on the benzene. Okay. And what is this? This is the question from NCRT. Very famous. What's the reason?
Sir, because it is SN2 reaction.
No, there is some other reason. Actually, we need to take HI if you want to react alcohol with if you want to convert the alcohol to alkyl iodide, you need to take HI. But HI is not there in the lab. Why it's not there in the lab? Why can't we have HI in the lab?
It's unstable, sir.
Yeah, it is unstable, it gets oxidized by air. So you prepare it by taking Ki salt and putting acid. But the sulfuric acid is again oxidizing. So you have HI. Okay. But if you have sulfuric acid, the sulfuric acid oxidizes it very quickly to I2. So I2 is of no use. We wanted HI only. Okay. Clear? So we don't want the HI. We want HI to form, but we don't want to get it oxidized by.
Sir, can you say what is the reason again?
Because H2SO4 is an oxidizing acid. It oxidizes the HI to I2.
Done, sir.
So will the reaction happen with I2 or you needed HI?
HI, sir.
So now the question is which, so suppose H2SO4 you can't use, so which acid will you use? To get HI? HNO3?
That is also oxidizing agent, sir.
That is also very strongly oxidizing. Yeah. You use H3PO. Remember it, this is a very important question. H3PO4, phosphoric acid. So phosphoric acid is a non-oxidizing acid. You take Ki plus H3PO4. So that will get you, that will convert the Ki to HI, but HI will not get oxidized further. Clear?
Yes, sir.
Right? So this is very important. Do remember this. This is, I think you understood very well. Okay, and this you know already, Darjan's process. Any doubts in this?
Sir, using dinyl right?
Using thionyl chloride. Yeah,
Yes, sir.
correct.
Sir, why we are using pyridine?
Actually, pyridine is used to absorb HCl.
Yes, sir.
Okay. It is used to absorb HCl. And using phosphorus halides,
Yes, sir.
that is clear. But all these reactions, remember, all these reactions will never happen on aromatic alcohols. They were not for phenol. Okay. They are only for aliphatic alcohol. Is it clear?
Yes, sir.
But with the phosphorus halide, the mechanism is SN2. Okay. So you can see that there is an inversion of configuration. Right?
Yes, sir.
And there is a question. So, Nabil, you are preparing for NEET or JEE?
Yes.
JEE. Okay. So this is a very famous question. Actually, it has been asked in NEET, but it is so common. I have taught many times in JEE Advanced also. For this, actually, so if you reacted with excess HI, what you will get? Because just now we were doing the reaction of alcohol with HI. So this is the same question. Excess HI, what you will get? This is glycerol. Okay.
Yes, sir.
And tell me what you will get. The IUP is the name of the compound. And this is a very good question.
Sir, propane 1,2,3 triiodine.
Yeah, 1, 2, 3, try iodopropane. Yeah, but actually, this is not the answer. What you thought is correct, but actually, there is something else involved in this. Actually, what happens is that there is one thing that iodides are unstable. Vicinal iodides are unstable. Okay. Why they are unstable? Because iodine is a very big molecule. The bonds are weaker, and if you have two iodine on the adjacent carbon, they just break away, and that will give you. So remember that if you want to add iodine to double bond, that also doesn't happen. Because if you add iodine, you will have I2 adjacent I on the carbon group, and that will break. So you will get this. Is it clear? Agreed or not? But you need to have the concept in the mind, which I told you just now. Just write it. Vicinal diiodides are unstable. Okay. Is it clear, Nabil?
Yes, sir. Then what will happen, sir?
Yeah, now there is a double bond. One more HI will get added. So H and I. Now I will do the Markovnikov addition, right?
Yes, sir.
So again, I will have vicinal diiodides, right? So now what will happen?
Dehydrohalogenation.
Yeah, again, dehalogenation, you will say. Iodine will break on its own. In NCERT also it is written that iodides gradually get darkened with time. Iodides get darkened with time. Why? Okay. Because the iodine breakaway. Okay. So again you have a double bond. If you have double bond again you will add HI. Again do the Markovnikov addition, HNI. So this is going to be the final answer because now you have only one H, one I. And now this is going to be the final answer. Is it clear?
Yes,
Got it? So it's a very difficult question. A lot of concepts are involved. Reaction of alcohol and HI. Vicinal iodides are unstable. Okay. And other thing is multiple times addition of HI, removal of I2, Markovnikov addition. Okay. So all these things happen. So the answer is going to be, the final answer is going to be isopropyl iodide. Is it clear? Right?
So can you show how a structure will be?
Yeah, this one. 2-iodopropane. Clear?
Yes, sir.
But this is not the question.
But it won't be formation of double bond.
No, actually double bond, when the double bond appears, the double bond actually the HI adds because I have taken excess HI. There is one more question related to this, that how many moles of HI are consumed by 1 mole of glycerol? That can come in integer
Sir,
type.
voice got cut.
How many?
Sir, your voice got cut.
Yeah, how many moles of HI? How many moles of HI will be consumed by 1 mole of glycerol? Got the point?
Sir, 3 moles, sir.
Yeah, 3 moles were
Yes, sir.
consumed instantly. 3 here. Then I2 got eliminated. 1 mole was consumed here. Right? And 1 mole was consumed here. Right?
Yes, sir.
So totally how many moles of HI got consumed?
Sir, 5.
Yeah, total 5 moles. Yeah, that can come in the integer type. Okay. Clear? Very, very important question. But not for CBSE. It is just for it. It has already come in the NEET papers few years back. So it's not a very common question, and now it can come in JEE also. Okay. Now here, if I ask you, what is the mechanism on, so that you know already, and you told me also that the substitution on benzene or aromatic halide is going to be very difficult. Okay. Because of the double bond character. Right?
Yes, sir.
So how it happens? How the reaction happens then? If it is very difficult, does it happen quickly, or do we need to take certain special condition to make it happen? And what's the mechanism? Is the mechanism SN1 or SN2? Yeah. That you can tell.
Sir, it will take place under extreme conditions.
Yeah, because benzene itself is a pi electron cloud. The Cl is doubly bonded. Okay. And the The nucleophile, if it tries to come in, it will be pushed away by the electron pair of the benzene. Okay. So you need extreme conditions. Yeah, that's true. And look here, the extreme conditions. 350 degrees Celsius and 300 atmosphere, right? So what
Yes.
what this reaction is known as?
So nucleophilic substitution reaction.
Yeah, nucleophilic, but we are doing all sub reactions till now on nucleophilic. You need to be more precise.
Sir, SN1 reaction.
No, this is not SN1. SN1 can't happen. The Cl can't come out on its own. This is SNAR. It is known as nucleophilic aromatic substitution reaction. Okay, bimolecular nucleophilic aromatic substitution. And this is neither SN1 nor SN2 because that SN1 or SN2 happens on only on sp3 carbon. Right?
Sir, SNAR is bimolecular.
Pardon? Yeah, it
Sir,
is
SNAR.
Yeah, it is bimolecular. Yeah, I will show you the mechanism, but it is not SN2. It is known as bimolecular nucleophilic aromatic substitution. Okay?
Yes, sir.
But
Yes,
not
sir.
SN2. Not SN2. Okay. That you need to know. Right? So, but it is not that every time it is difficult. So you can see the temperature getting down. And if you have 3 NO2 group, that happens very easily. Just you need to warm it. Okay.
Yes, sir.
So it happens very, very easily. So what's the mechanism? Look here. Is this clear? Mechanism.
Yes, sir.
This is bimolecular NAS mechanism, and this is because slow step is involving two things. So that's why it is having, it depends upon the concentration of this. Okay. So this mechanism is clear, right?
Yes, sir.
Okay. So what's the
Sir,
rate?
but
Yeah.
you have to always show the resonance, sir.
Yeah, resonance, actually it will not be asked, but you need to keep it in mind because this only will tell you why the NO2 group present at the para position will make the reaction easier.
Yes, sir. But how can you say that it is easier, sir?
Because this minus charge can get stabilized by the presence of NO2. It can undergo more resonance with the NO2 group. If NO2 is suitably placed, means at ortho and para positions, then only the minus charge will get more stable.
Yes, sir.
Okay, but electron donating group will make it unstable. Okay. So what about this one? Yeah.
Sir, BCA.
B is going to be the fastest, C and A. Yeah, correct.
Sir, but The electron withdrawing group at ortho position will have greater effect, right, sir? Ortho and
Yeah,
para.
yeah, it will have greater effect because the negative charge is passing from ortho and para position. So you need to have that group right at that ortho and para position so that it can get delocalized with the NO2 group. Okay,
Yes, sir.
right? So, but if you have electron donating group at ortho and para, that will have opposite effect. OCH3 group will make it reverse. Okay.
Yes, sir.
Right. So this is clear. And what about this one? Then all you have studied. So how many chapters you have studied in CBSE till now?
Sir, we finished alcohols, doing aldehydes, ketones, carboxylic acids. We started it today.
Okay, okay, good. So yeah. So this is preparation of phenol. So you know that all of these are preparation of phenols. All of these are the method for the preparation of phenol.
Yes, sir.
Okay. So which one is Dow's process?
Sir, C, sir.
C is not the Dow's process. No. Dow's process. Yeah. Just now we discussed.
Sir,
You know it.
D.
No, A. The one which we discussed just now. That is Dow's process only. Okay. So it is named
Yes.
after a very Dow is also a very famous company, chemical company of US. Okay. And that is the Dow's process for the A, right? Don't forget it. And what's the name for B? That is also a very famous named method for the preparation of phenol. Which one?
Pope's electrolysis.
No, 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 no. We are not doing electrolysis. Very famous method. Okay, I will give you a hint. Start from C. CU. A name.
From cumene.
Yeah, cumene hydroperoxide method for the preparation of phenol. This is cumene only. Cumene is what? Isopropyl benzene. Okay.
Yes, sir.
So, but do remember this. This is very, very important. Okay. Uh, this just you can do it now quickly, and so this is SN1, and the BR will come out very easily. Okay, so that's why you have acidic solution. But in the second one, the BR can't come out. Why?
Sir, why first one is acidic, sir?
Because as the SN1, the Br can come out very easily.
Yes, sir.
It is SN1 and the cation is very stable. It is tertiary. Okay. Got it?
Yes, sir.
But what about second? What mechanism is second?
Sir, SNER.
Yeah, that is biomass. So that can't happen actually because the temperature and all are not given. You can see that just ethanol is given. That will not make it happen. Okay. Yeah, it is SNAR. So it will remain neutral that because Br is not coming out, so reaction will not happen. And in the third one, F minus came out. Why? Why the F minus got liberated in the third reaction? In the B first part. Yeah.
The presence of electron
Withdrawing. Yeah, yeah. Right. That's now we have seen. Okay. And why can't the F come out in the B second part of B?
Sir, because the electron withdrawing group is not directly attached to benzene ring.
Yeah, yeah, yeah. Exactly, exactly. Okay. So now you have noted